The following was recorded in March 2019 at the Endocrine Society's annual meeting in New Orleans.
Hello, I'm Aaron Lohr, and this is the Endocrine News Podcast. We're talking about BPA exposure and circadian rhythms. Joining me today on the podcast is Dr. Deborah Koresh, Associate Professor at the University of Calgary, and Dr. Dinu Nason, a postdoctoral fellow at the University of Calgary. Thank you both for joining us today.
Thank you for having us.
Thank you.
Your endo presentation is titled Low-Dose Gestational BPA Exposure Alters Circadian Rhythms in Mice. Why should we be concerned about alterations in circadian rhythm?
I think the real answer is that so much of our body processes, our physiological set points are under this daily control where they undergo what's called a diurnal rhythm, a circadian rhythm, where each day they're rising and falling predictably. So that controls sleep wakefulness, your locomotor activity, your body temperature, and also when you get into your cells specifically, lots of different cellular processes undergo this as well. And they're all controlled by a master clock in the hypothalamus, in the suprachiasmatic nucleus, which is what we're studying here in this investigation.
And if we start playing with that master clock and these alterations start to happen, what are some complications we might see from that sort of thing?
Well, so you experience it in your day-to-day process. If you go a long while without sleep, or you undergo sleep deprivation, or you travel and you're randomly changing or suddenly changing your light cues, all of a sudden you just feel run down, right? You're more tired, or you're more irritable, or you can see changes in your weight gain if you're doing this over time. There are all these factors that are under this circadian control that end up being altered and having kind of a detrimental effect if your body clock gets unsynchronized.
And there's been a lot of studies in recent years about the dangers of exposure to endocrine disrupting chemicals like BPA, which we're going to talk about. But why is exposure specifically during pregnancy concerning?
The pregnancy is a window of vulnerability for endocrine disrupting chemicals because the brain is developing during this window, and sex steroids can influence brain development. So estrogen, testosterone can play a role in how the brain develops. So if you have a chemical like bisphenol A that can mimic estrogen in particular, it could then influence processes at the wrong time or at the wrong place when we don't want it to. And so I think that's the primary reason that we're concerned about if mom has high exposure to these bisphenol compounds, that it could then go in and modulate the cells in a time and a way that we don't necessarily want that to happen.
So we're going to talk a little bit more about your study, but there's been a lot of studies about BPA and, is it safe or is it not safe? And a lot of people who are listening to this are probably wondering, why is there still a debate about this?
This is the million-dollar question, and I get this question a lot. And I think the best answer is that it's complex. And so I'll tackle it in two main ways. The first is methodology. In academic science, we use different assays to measure disruption. We don't rely on some of the toxicology methodology that's being used within government labs. And it makes sense that government labs have very standard, very set assay protocols that they've relied on for many years. But these endocrine disruptive chemicals do not follow the same properties as general chemicals do. Notably, these chemicals do not follow a simple linear dose-response curve. And I think this is one of the areas that academic science and governmental science has been different. The other is on a more pragmatic level. In academic science, we're quite comfortable with a 95% confidence interval. We're comfortable saying, well, within 95% confidence, we believe that there's an effect here. And that's not necessarily how the government, they have a more obligation to keeping the people safe, and they must be very confident in what they're putting forward. And you can imagine if the government came out and said, we can't have plastics anymore, that would be very disruptive to society. How would you bring your to-go container from the restaurant?
It's everywhere.
Where would you bring your coffee in from work? And it has very real-world ramifications that I think make this a very complicated dynamic in regulatory circles. I'm not in the regulatory agencies, but I do say on the science side in academic labs, the data is quite conclusive that there is some perturbations happening in our body in exposure to bisphenol A.
And one of those perturbations that we're talking about today is these alterations in circadian signaling. So in your study, how are you able to measure that and then connect those alterations to BPA?
So we've been doing this kind of work, especially in terms of maternal exposure to BPA, for a few years now, and prior to that, we were looking at it in zebrafish. So we've already kind of established that the hypothalamus in development seems to be this region of specific susceptibility to BPA disruption. And we've also found in all our models, and it's shown sort of elsewhere in human cohorts, that hyperactivity seems to be a really common phenotype that comes out of early life BPA exposure. So what we've done here is we've taken our mice, we've fed pregnant mice our BPA diet at these low dose, environmentally relevant levels, and then we've taken the offspring, let them grow up, and then we put them in these singly housed cages with a running wheel. And mice love this wheel. It's enrichment for them, and they will just get on and they're really enthusiastic about running, as opposed to what you or I might be.
Indeed.
And so we were able to monitor them 24 hours a day in these specialized cages by digitally kind of tracking the wheel turns. And then we're also able to play with their light-dark cycles. So we look at, first of all, their overall activity in a normal 24-hour day with half light, half dark. And then we move them to 24-hour darkness to see that's really where you can get at how the circadian rhythms shift or change, because you remove these light cues that stabilize our 24-hour day clocks. So then they're into what we call kind of their intrinsic circadian days. And so that allows us to see that BPA mice are indeed much more active, almost 1.5 to 2 times more active on a course of a 24-hour day, both either normal light dark or 24-hour darkness. They also tend to be active for longer stretches of time. And we find, most interestingly, when we move them to that dark period, their intrinsic day is shorter. So they kind of move out of sync with the control animals over time, the longer you leave them in this 24-hour darkness. Because where your circadian clock or my circadian clock might be 23 and a half or 23 and 3/4 hours, theirs is 23 and a third or 23 and 15 minutes. So every day they move 15 minutes more ahead of you and I, or the control mice, out of sync. So we were able to find that there is this linkage when you expose them in utero and look at their activity later. And then we were able to look within the hypothalamus at the suprachiasmatic nucleus. And we found that there were some changes in neuropeptide expression, specifically vasopressin, and also some changes in how they respond to light exposure. That really seems to be that's where the disruptions during development are occurring that cause these changes later on.
So I want to ask you about the BPA dosage. How does it compare to the sort of amounts of BPA that I might be exposed to on a given day?
We prepare our diet with a set amount of BPA in it, and we're able to track how much the mothers eat, and then we're able to take the fetal serum and measure it there to see how much BPA crosses the placental barrier and gets into these animals specifically. So when we do the math on this, we end up being about 20-fold lower than what is the recommended safe daily intake by North American and European health agencies, and about 350-fold lower than what is found in human fetal cord samples. So we're in levels that if you take them to a government regulatory body, they would tell you this is fine. But yet we're still seeing these alterations in our animal models.
So this is concerning, and a lot of people who are listening right now are probably thinking, how do I limit my exposure to BPA? What can I do? Is there anything that I can do?
Sometimes I get people calling me on my cell phone at home actually saying, I'm a pregnant woman and I work in the store, and do you think I should quit my job? And so, I'll tell your listeners the same thing I tell her. No, you don't quit your job. The stress of not having income is probably greater than your exposure to BPA, so don't quit your job. I think we, calm and smart minds need to prevail is kind of the advice that I give, that we're exposed to all sorts of contaminants and pollutants and toxicants in our daily life, and we can't live our life in fear, so we do our best to limit exposure, as we can. So, for example, don't heat your lunch in a plastic container. Don't pour scalding boiling water into a plastic cup. Don't put your plastics in a dishwasher. Heat breaks down the plastic so that bisphenol A can leach out. And so if you do everything you can to not break the integrity of that plastic, that will help. So don't scratch it, don't heat it, don't abuse it. There is an argument to throw your plastics away after a period of time and get new, but then that fills landfills. So probably the best thing is not to buy plastics if you can. My other piece of advice is, if you're a person that doesn't need your thermal receipt paper after you charged your credit card, just say no thank you. There is BPA on the powder. That's how they get the ink to stay on the paper. And so if you don't need it, then just don't get it. And it saves the cashier and you one more contact with it. If you do have to handle them, it's best not to have lotion on your hands or something that might help the uptake. But I think the overall message is try to use glass when you can, try to use aluminum water bottles, try to limit your exposure, especially to single-use plastics, but also plastics that you carry your food in. Get glass whenever possible for your storage. And then you live your life. You do the best you can.
Sounds like sage advice. Well, I wanted to thank you both for taking the time and joining us on the podcast today.
Thank you. It's been great to be here.
Thank you, Aaron.
That's all for this episode. Thank you for listening to the Endocrine News Podcast. To learn more, visit www.endocrine.org/podcast. There you can find this episode and some helpful links. You can subscribe to Endocrine News Podcasts on iTunes or wherever you get your podcasts. Be sure to leave a review on iTunes. And if there's a topic you'd like to see us cover on the podcast, let us know by emailing us at podcast@endocrine.org. Thanks again for listening.
Endocrine News Podcasts are a free service of the Endocrine Society. To learn more or to become a member, visit the Society's website at www.endocrine.org.